So binomial distribution. Binomial distribution is generalization of binomial trial. Remember, binomial trial means you have random experiment which have two outcomes, failure or success, and success probability p, and failure is 1 minus p. So now binomial distribution is a generalization to allow it to be n independent binomial trial. Okay. So the support, of course, x can take the value from 0 to n because there's 0 success, 1 success, up to n success. So the probability or probability distribution function f of px, okay, will be ncx px and 1 minus p to m minus x. Okay, why that's the case? So if you want x success, okay, what is the probability? Is p to the power x, right? Because x success, 1 minus p to the m minus x, right? So this is the joint probability that this would happen, okay? Suppose you have first time we have x success and we have all them failure. So this is probability, okay? But there are different way that we can organize the x success, right? Because can be first x is success, right? Can be the last x success, can the middle x success, can be success failure until you have x success, right? So how many different way to have x success is n, you have picked x, right? So that's why it's ncx and times that, okay? So the mean of a binomial is np, and the variance is np times 1 minus p. So we'll prove that later, soon. So let's see the graph. So if p is half, so the distribution function, okay, probability distribution function is if symmetric. You can see the red one, right? Symmetric about is mean also, because np is 3, so this is the mean, okay, for the red one. For the blue one, mean is 1.2, okay? So that you can expect this is not very symmetric, right? Because this is mean and this is a asymmetric one, a positively skewed one. So an example would be, suppose 30% of his customer like spicy food, okay? So if you randomly pick a customer, like 30% of them will get the customer like the spicy food. So binomial trial. So suppose he repeat this and pick up 5 randomly drawn. We're asking probably 2 of them like the spicy food. So it's a binomial distribution. Okay, n is 5. Okay, p is 0.3, and we want to see what's probably x equal to 2. So it's then directly apply the definition, right? Is n5c2 and p is 0.3, 0.3 to the x is 2, and 1 minus p is 0.7 to the 3. So you can easily check by calculator. It's 0.1543, okay? So now we are going to prove this expectation is equal to np. So the goal is to prove is np. So expectation x, right, by definition x times px, right? Px is ncx px and 1 minus p minus. So this part is the definition, right? And here the first trick is x is 0, right? So you can start from 1 because 0 times everything is nothing, okay? And the next trick we're doing is x times nx, okay? Can be, you can take the n out, okay, and the x out, okay? You can change it to n over x times n minus 1, x minus 1, okay? So the x cancel out less than with n, okay? So that's a trick here, okay? You can, ncx can take out is n over x, n minus 1, x minus 1, okay? So that's why when you take n over x out, x cancel out left with n, okay? Why do we want to do that? So you can take the n out, okay? And we can replace x plus 1, so x minus 1 by y, okay? Replace everything, x minus 1 is y, so x is y plus 1, okay? Y plus 1 and y plus 1 here. And then, so x from 1 to n, which means y from 0 to n minus 1, okay? Then you have a p here, take out the p again. So why we want to do that? Because this guy, okay, is a binomial distribution, okay? Here is a binomial distribution of n minus 1 p, okay? So the summation of all probability is 1, okay? So that's why I have np, okay? There's a trick we use to do it, so we will use the trick again in the next few slides. So to find the variance, so we will do the shortcut of find the second moment, which is x better x squared. Why? This is good because here we will use this formula, okay? X better x squared minus square of the expectation, okay? So here x squared, so with the same trick, x equal to 0 is not meaningful, so you can take from 1, and we can take n out and x out, okay? Cancel the 1x, and you have nx, right? n minus 1 x minus 1, okay? And then we can do the same trick, right? X is equal to y plus 1, okay? Then you start from 0 to n minus 1, and everything replace x to y plus 1, okay? And here, because x is y plus 1, so it's 1p here, we take out the p, so that's why it's np times this guy. And note that this guy, right, is exactly what we said is the binomial distribution n minus 1 p, so that's why we have 1 can be taken out by np. And what remaining here, okay, again the same trick from y, so it's the same trick here. Y can be written, you can start from 0, 0 doesn't really matter, you can start from 1, okay? The same trick would apply like what we have here, right? The same trick here, okay? So same trick here, we can take out n minus 1 and y cancel out, okay? That's why we have n minus 2, y minus 1. And here the same trick apply. We can take the p out, okay? So that's why we have p squared, okay? And that's why we have n minus 1 and p squared, okay? And now we have variance of x is this guy minus that guy, right? So we have shown n times n minus 1 p squared plus np and minus np squared, okay? And you can easily see that the np squared cancel out, okay? N squared p squared. So that's why it's np times 1 minus p. Okay, that's all for the binomial distribution.